This video is about a quick tutorial of descriptive statistics in Microsoft Excel using Windows. I will start with histograms, how to make histograms. So we have this data that's about height and weight, and I will select this whole column by pressing Ctrl, Shift and page down arrow key, and then click on Insert, Histogram, and here we have histogram. Now let's label it, and then we can further refine it. You can see here a plus sign. If you click on this plus sign, then axis title appears. Now we can add here weight, and here you can add frequency. And regarding these bins, if you click on these numbers and then format axis, we can adjust here bins. So for instance, number of bins. Right now there are 6 bins and you can change them to, let's say, 10. And then bin width can also be changed. Right now it's 5. Let's say if I change to 6. And then we can also round them. Click on number and then decimal places. Let's say I say 0 decimal places. Then the next thing is calculating skewness and kurtosis of this data. There are two methods to calculate skewness and kurtosis. One is simply this formula, that's skew, and then select this whole column, Control Shift and up arrow key, and skewness turns out to be 1.05, which means that this histogram has a tail on the right side. Then let's see kurtosis, and for kurtosis, KURT, and select this whole column except the label row, that's a top row, and kurtosis turns out to be 1.14, which is slightly above 1, and it means that our histogram, it had a little bit peakedness. It was a little bit tall, thin, and there was a peak. There is another way to calculate skewness and kurtosis, and for that click on data and then data analysis. If data analysis is not there, then you need to add in. For that purpose you will go to options and then add-ins, and then after that Excel add-in, go, and here you have analysis tool pack. So if I click on data analysis and descriptive statistics and then input range, I want to calculate skewness and kurtosis of this column. So I will select this column except the top row, label in first row, I didn't select that. Output range, where do you want your results to appear? I want my results to appear here. And what do you want? I want summary statistics. Okay, let's click OK, and then it gives us a different type of descriptive statistics including median, mode, standard deviation, variance, kurtosis, skewness. And as you can see here, this kurtosis and skewness, they're exactly the same that we calculated manually. Skewness is 1.05 and kurtosis is 1.14. So that's another way. It also provides us range, minimum, maximum, and count how many rows are there. The next one is mean. Mean can be obtained from here, but you can also calculate it manually, and that would be average. And again select this whole column. And the next one is median. Median we have here, that's 44.96. We can also calculate it manually, median, and then select this whole column, and median turns out to be 44.96. That's exactly the same as we calculated in descriptive statistics. Now the next one is geometric mean. And geometric mean, the basic idea of geometric mean is that we know arithmetic mean has certain limitations, and geometric mean can address those limitations. So for instance, let's say here's a mutual fund that gave a return of negative 22.1% in year 1, in year 2 28.7, in year 3 return was 10.9%, and then in year 10 it was 2.10%. How much they can expect, I mean, if they make an investment in your company, then how much they can invest. No, there is a lot of variation, and in the first year there is also a negative value. So for this purpose we need to use geometric mean. I will show you how arithmetic mean results differ from geometric mean. Now let's say first if we do it manually, we say you want to make an investment of 1000 and in the first year a return turns out to be negative 22.1%. How much would be change? We would say 1000 multiplied by this one, and which means in the first year you incurred a loss of $221, and then your investment at the end of the first year became 1000 plus 221, which means it will be automatically be deducted. So 1000 minus 221, that will be 779. Now this $779 becomes your starting point in the beginning of the second year. It shows that your investment at the end of 10 years will become 1334. Now let's do this with arithmetic mean. Now this is arithmetic mean. In arithmetic mean we will take average. Okay, let's take average is equal to, this average turns out to be 5.04. Okay, if we use this average to figure out how much we can expect, which means if this 5.04% change happens every year, then how much I can expect at the end of the 10 years. Your starting investment 1000 multiplied by this arithmetic mean, and make sure when you are using this 5.04 you press Fn and F4, which means we want to lock it, because in the next step I'm going to drag it down. So, and whenever we have to drag it down, that particular value, it should be frozen. Your investment at the end of the first year will become 1000 plus this change 1050.4. Now if I drag it down, it says that by the end of 10 years your investment will be 1635. Now let's do geometric mean and see what would happen. For geometric mean we will use this formula is equal to geomean, but before that just make sure that all these values have been converted into percentages, and then plus 1 parenthesis minus 1, and then you need to press Control Shift Enter. Sometimes just pressing enter does not work because it's an array function, and it says that geometric mean is 2.93%. Okay, let's use this value. So when we will be using geometric mean, your starting investment, it's 1000 multiplied by this change 2.93, and make sure lock it Fn and F4, and you can see dollar signs appear there. Let's add them up is equal to this one plus 29.3, and that will become 1029.3. Okay, and if I drag it down, that gives us 1334, which is exactly the same as we calculated manually. Now you can see there's a big difference between this 1334 that we get from geometric mean and 1635.1 that we get from arithmetic mean. This means that arithmetic mean is not giving us correct results, and to address that limitation we use geometric mean. Range, standard deviation and variance. Although we have already done this in descriptive statistics, standard deviation is equal to ST DEV, and select this whole column. So that's standard deviation. And then there is variance. For variance is equal to variance. Now remember, if we take square root of variance, it will give us standard deviation. Square root of variance, and that should give us standard deviation. So you see this number and this number, they are identical. So standard deviation and variance, they are very much similar concept, but standard deviation is more intuitive, it's more frequently used. Then the next one is quartiles. For quartile we have this formula, quartile, and this whole data selected, and then enter 1, that's the first quartile. So first quartile will be this one. So again the formula is this one is equal to quartile, data selected, and 1 means first quartile. To get second and third quartile, I can drag it and I can just make here changes. I will write here 2, and here I will just replace 1 with 3. And for percentiles we have this formula, selecting the whole column, and then if I want to get 70th percentile, I will write there 0.7, and this gives us a 70th percentile. So this is the formula I'm using, percentile. Now the next thing is standardized scores, and for that we use this data, that is treadwear. Let's say choose one variable that's standardized miles, and this requires three things. And as you can see, it will also appear here. If I write here standardize, I type parentheses, then it says we need x. This is the value of x, and then we need mean and standard deviation. So which means that before we can use this formula, you need to calculate mean and standard deviation. This is x value, and then comma mean, that will be at the bottom. Make sure when you are using this value, you lock it by pressing Fn and F4. We need to lock it because in the next step I'm gonna drag it down to fill the whole column. And then it says standard deviation. Standard deviation is also given at the bottom of this column, and that will also be locked by pressing F and F4 and then close parenthesis, hit enter. So this is 3.470. Now I will drag it down. They have already been sorted in descending order, which means largest values, they appear at the top. Now these values, they are greater than 3, which means they could possibly be outliers. In this case, you will go back to your data and see, because normally these standardized miles or standardized values, they should be between -3 and +3. Anything that's less than -3 is problematic. Anything that's above +3 is also problematic, which means they could be outliers. Now you go back to your data and see what is the problem with this one, why they have so high standardized score. And actually you can see here that these values, they are in 6 digits while others are in 5 digits. The next one is box plot. So for box plot, I will select this whole column and then click on insert, and then let's click on recommended charts, all charts, then box plot should appear. So here is box and whisker at the bottom. So if I click box and whisker, it gives me this plot, and you can label it, you can enter here box plot, and let's refine it a little bit. So this is minimum value, this is Q1, this is Q2 or median, and this is Q3, and this is maximum non-outlier, and this is another value which is an outlier. Add data labels. So it shows that this value is an outlier. Then scatter plot and correlation. Let's say if we start with scatter plot, and if I select this data, again I click on insert, and then in scatter plot, if I click on this one, it gives us this scatter plot. Now if you want to refine it further, especially you see this area that's blank and it does not has any value, so I would like to trim it. I would like to start it with 20. So I will click here on y-axis and then format axis, and here I say I want to start with 20. Right now it's starting with 0. I will like to start it with 20. Now here this y-axis now starts with 20, and that seems much better. You can always change it and make different designs. And the last thing is correlation. Correlation is equal to correl, C-O-R-R-E-L, and then first column, comma, second column, close parenthesis. So that's 0.93. If I convert it into percentage, that will become 93.25%, which is a very strong correlation.